What's up, everybody, and welcome back to another math puzzle. In this one, the question is as follows. 5 squares are shown below. Find the area of the red square. Now, just a quick shout out, this puzzle is taken from Catriona Scherer and slightly modified, but you should definitely check out her website. She's got tons of puzzles like this. Hit that pause button and see if you can figure it out. When you're ready, hit play and I'll give you the explanation. All right, so you see that we've got all of these squares, right? And then this one is one gigantic square. So the cool thing about squares is we know the side lengths are equal, and what times itself is 9, that is 3. What times itself is 36, that is 6. And what times itself is 81, that would be 9. So we've got these side lengths all here everywhere, and this is terrific. Now again, since we're trying to find the area of this giant red square, we only need one side length, right? Because if we get one side length, we can square it and we're gonna get to the area. Okay, so let's figure out how we can do that. Now, you might notice that we've got 1, 2, 3 triangles presented here. And not only are those 3 triangles nice and right triangles, by the way, but they also comprise one side length of the square if you add up all the hypotenuses. So, and why do I say that they're right triangles? Because these have to be right angles, because these are all squares with right angles on the other side, right? So we know that these are 3 right triangles. We also know that since this line is kind of going down and touching all of them and comprising all of their hypotenuses, since this line is parallel to this line is parallel to this line, right? Because all of these squares have a bunch of right angles. That means that this angle is equal to this angle is equal to this angle, meaning by angle similarity, we've got 3 similar triangles. Now we can start our process of figuring out the length of this square. So first of all, I see that this side length is 6 right here. And if this is 6 and this whole thing is 9, I can see that this right here has to be 3, right? The difference of 9 and 6. So now I can see that all of these right triangles have a 1:2 ratio for the 2 legs, okay? And that's really helpful because if they're all similar, they all have that same proportion, meaning if this side length is 3 of this triangle, this is gonna be 1.5. If this side length is 9 of this triangle down here, this is going to be 4.5. Now we can use Pythagorean's theorem to find all of these lengths, which I'm gonna now highlight. We've got that hypotenuse, we've got this hypotenuse, and we've got this hypotenuse in orange. So the first one is gonna be 1.5 squared plus 3 squared is equal to c squared. Or the other way to think about it is I'm gonna have to take the square root of this anyways to solve for c. So this first one is gonna be the square root of 1.5 squared plus 3 squared. Following that same logic to get the next one in purple, we're going to say 3 squared plus 6 squared, and we're taking the square root of that. And last but not least, for this color, we're gonna have 4.5 squared plus 9 squared, and we're taking the square root of that. Now, if we add all these together, we're gonna have the full side length, and then to get the final area, we're gonna square that value. So to do this, I'm gonna use a calculator. Let's use Desmos. So as you can see right here, we've added all these values up when we get this irrational number for the side length. But again, to get the area, we gotta square this entire value. So putting parentheses around it, raising it to the 2nd power, and we get 405. So that means our final answer is 405 feet squared for the win. Boom, done. I hope you guys enjoyed this math puzzle, and if you did, please click that like button. If you want to see more math puzzles on the regular, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.